Have you ever gazed at the night sky and pondered the possibility of life on other planets? Our universe, a boundless expanse of cosmic wonder, is teeming with uncountable galaxies, each brimming with an array of planets. These celestial bodies, scattered across the vast canvas of space, are a testament to the universe's infinite potential and diversity. This enormity of existence inevitably raises a tantalizing question. Could there be life beyond our blue marble? Is it possible that somewhere amidst the countless planets, life as we know it has taken root? But let's take this speculation a step further. Imagine if we could take barren, uninhabitable planets and reshape them, turning them into a second home for humanity. A process that seems straight out of a science fiction novel, but could be closer to reality than we think. If life as we know it could exist elsewhere, shouldn't we explore how to make that happen? Scene script. Enter the concept of terraforming, a process that could potentially make other planets habitable. So what exactly is terraforming? Well, in simple terms, it's the hypothetical process of deliberately modifying the atmosphere, temperature, and ecology of a planet to make it similar to Earth's biosphere. That's right, we're talking about taking a planet that's cold, barren, and inhospitable and converting it into a place where life as we know it can thrive. Now, let's break this concept down a bit further. Terraforming is a word that's derived from the Latin words terra, which means earth, and forma, which means shape or form. So essentially, it's the process of earth shaping a different planet. The aim of terraforming is to alter a planet to such an extent that it can support an Earth-like ecosystem. This would involve changing its atmosphere, manipulating its temperature, and reshaping its surface topography. For instance, we'd need to find a way to generate an atmosphere that can retain heat, block harmful solar radiation, and support the chemical reactions necessary for life. But here's the thing. Terraforming is largely a theoretical concept at this point. While it's a popular topic in science fiction, we're still a long way from having the technology or understanding necessary to actually terraform a planet. It's a gargantuan task that would require a level of technological sophistication far beyond what we currently possess. Yet it's a fascinating concept to ponder. The idea that one day we might be able to shape the environments of other planets to suit our needs is both thrilling and daunting. It would open up a whole new world of possibilities for space exploration and colonization, perhaps even providing a solution to the existential threat of Earth's finite resources. Imagine the possibilities if we could master this process. It's a prospect that invites us to dream big, to reach beyond our current limitations, and to envision a future where the stars are not just destinations to reach, but also homes to inhabit. This is the allure of terraforming. Terraforming is a complex process. It involves a number of steps and requirements that need to be met. Let's embark on this intricate journey, step by step. The first stage of terraforming is atmospheric adjustment. This involves altering the atmosphere of a planet to make it similar to Earth's. This could mean increasing the atmospheric pressure, changing the composition of gases, or both. The challenge here lies in the sheer volume of gases needed to effect such a change. One potential solution could be to use comets, rich in volatile compounds, to increase a planet's atmospheric density. Next comes temperature control. If a planet is too cold, we would need to introduce greenhouse gases to trap heat and increase the temperature. On the other hand, if it's too hot, we might need to reduce the amount of sunlight reaching the planet's surface. This step is fraught with uncertainties. Controlling a planet's temperature is a delicate balancing act, and slight miscalculations could lead to catastrophic results. However, advances in climate modeling and simulation technologies could help us overcome these challenges. Once we have a suitable atmosphere and temperature, the next stage involves the introduction of life forms. We would start small with microorganisms, which could help in creating a breathable atmosphere by producing oxygen. Gradually, more complex forms of life could be introduced. The challenge here lies in ensuring these life forms can survive and thrive in the new environment. Genetic engineering could potentially play a key role in creating organisms that are adapted to survive in these conditions. But let's not forget, terraforming isn't just about the science. It's also about ethics. Should we alter another planet, potentially eradicating any existing life forms or ecosystems? And who gets to make these decisions? These are questions we must grapple with as we venture further into the realm of terraforming. As you can see, terraforming is a monumental task, but one that holds immense potential. Scene script. Let's take Mars as an example. It's one of the most talked about candidates for terraforming. Why Mars? Well, it's not just because it's our next-door neighbor in the cosmic neighborhood. Mars shares a few key similarities with Earth, which makes it an attractive prospect for terraforming. It has about the same length of day as Earth, a little over 24 hours, and a similar tilt on its axis, which means it experiences seasons just like we do. What's more, Mars has water. Not flowing rivers or vast oceans like on Earth, but significant amounts of water ice, especially at its polar caps. This presence of water is crucial because, as we know, water is the elixir of life. But terraforming Mars isn't as simple as packing our bags and moving in. The red planet presents its own unique set of challenges. Its atmosphere is just 1% as dense as Earth's, which means it doesn't retain heat very well. This, combined with its greater distance from the sun, results in temperatures that often dip below -80 degrees Fahrenheit. And then there's the issue of its thin atmosphere, which doesn't provide much protection against harmful solar radiation. These challenges might seem insurmountable, but they're not deterring the scientists and engineers who are dreaming big and thinking creatively. Potential solutions range from importing ammonia-heavy asteroids to thicken the atmosphere and warm the planet, to constructing giant mirrors in space to reflect sunlight onto Mars's surface. Some even suggest releasing greenhouse gases to initiate a sort of artificial global warming. Each of these solutions comes with its own set of challenges and ethical considerations. But the fact remains that these ideas are being seriously considered, researched, and refined. Terraforming Mars is a monumental task, one that will require an unprecedented level of international cooperation, technological innovation, and sheer human willpower. Terraforming Mars might be a distant dream, but it's a dream that scientists and engineers are working tirelessly to make a reality. Terraforming is not just about making other planets habitable, it's about the survival and expansion of the human species. Indeed, the benefits of terraforming extend far beyond the creation of new homes for humanity. By transforming inhospitable planets into livable environments, we could potentially alleviate the increasing population pressure on Earth. Imagine a future where overcrowding and resource scarcity are issues of the past, where the vast expanses of space offer endless opportunities for growth and development. Moreover, terraforming could unlock access to new resources. Just consider the wealth of minerals and other valuable materials that might be waiting beneath the surfaces of Mars, Venus, or even farther-flung celestial bodies. The economic implications are staggering. Not only could such resources fuel our expansion into the cosmos, but they could also help us address many of the challenges we face here on Earth. Yet there's another, perhaps even more crucial aspect to consider. Terraforming could be our contingency plan, our insurance policy against potential global catastrophes. Whether it's climate change, nuclear war, or an asteroid strike, having a second home in our solar system could ensure the survival of the human species. However, as exciting as these prospects are, we must also grapple with the ethical and practical challenges of terraforming. Do we have the right to alter entire planets? What happens if we encounter extraterrestrial life? And of course, there's the question of feasibility. Can we actually achieve these grand visions, or are they simply the stuff of science fiction? These are complex issues, and there are no easy answers. But one thing is clear. The future of terraforming is an exciting frontier, a realm where science, ethics, and imagination intersect. It's a field that invites us to dream big, to push the boundaries of what's possible. The future of terraforming is uncertain, but it's a field that promises to redefine our understanding of life and our place in the universe.